you will choose the theta. So at each round, you will choose the theta. You will observe some X or Y or whatever, and you will get some marks or score or points based on that. And based on this data and your inference and whatever prior you have, you choose the theta for the next round and so on. So, for example, let's say you are playing against your team is playing against a new team whose players you don't know much. So, let's say there are different kind of players who are like there are different kind of pitchers. Let's say in baseball, who are better against particular style of play of the batsman. So, the first round of pitch, you don't know which batsman is good against what. So you try something. Second round, you will try to like improve your selection of pitchers against a specific batsman, best matchup, etc. But your score is also taking like the what happened in the first round also matters to the final score, and your ultimate objective is to optimize your final score. Like let's say there are 18 rounds or whatever in baseball, cricket there are 2 innings or something like that. So you try to optimize your end result, but like you're learning as and when you are playing the game.
Okay.
So
I've
this
heard
is
that.
something like happens practically across a lot of areas of people where people do machine learning. You
Didn't
don't get to like get the whole data and then do an analysis and then start the game. You play the game as and when you get data, you analyze, choose the best action for the next round.
got it. Didn't
So that's the reinforcement learning
um,
part.
I think this when you're talking about this, it reminds me of the DeepMind story with the AlphaGo. Was that reinforcement learning?
That's not really reinforcement because like they analyze the whole thing beforehand, kind of.
Okay, so it's
And once that you're playing the game, it's not like that. But you can read about these kind of things. So there is multi-arm bandit,
say again?
multi-arm bandit.
Multi
The arm, arms like in hands,
T-arm bandit.
bandit. This is a very word name for a very standard problem, which is basically you are doing some decision making. And this applies to all kind of like business problems where you try to optimize your final revenue or profit or score or result or whatever, or
Okay.
accuracy or fit, like all kind of things where like these kind of things. So this is like okay, a simple setup will be like this. Suppose you have 5 coins. You don't know which ones, every one of them has a different probability of head. You don't know the probability of heads, but 5 are all different. Okay. Now you are allowed 100 tosses and you have to maximize the total number of heads. So one strategy could be, okay, I will toss each coin 5 times first. So I'll get 25 tosses basically wasted just to learn how the coins behave.
Right.
And based on those, I will use maybe future tosses on only those coins where the hit proportion was higher.
Yeah. Okay.
And I can keep learning and keep improving and keep deciding dynamically which ones I will toss at any given point.
Okay.
Okay. And then your final objective is to maximize something.
Got it. That's cool. Okay. I can see how that can be taken. Like I know coin example is like a toy example, but
Yes.
I can see how that grows
Yes.
from there then.
Yes.
Got it. Oh, so that's why they have the multiple. Okay, got it.
Yes. So you have multiple choices. You can choose at any point. The process is probabilistic in some sense. It might be coin tossing, it might be some random noise or something coming into the data and all that, because of which you cannot like infer exactly what is happened like every time that will be repeated. So there is some noise component to it.
Got
And
it.
then you are trying to optimize, basically optimizing under noise.
Got it.
That's the idea.
Cool. Optimizing your noise. Got it. And this is like a portion of deep learning, then, is what you're saying?
This is related to deep learning in the sense that when the problems become really big, where like the linkage function between X and Y becomes complicated, then people use this deep learning along with this.
Got it. That's funny that you mentioned the linkage function. That's what I want to learn today as well.
Yeah, GLM has all those things here, linkage functions. So that's basically where this is like a lot more complicated than a GLM, but in the similar direction.
Got it. Got it. Okay, cool. This is a cool one. I like this as a
Yes.
suggestion. This was the other one I was seeing here, Sujay,
Learning from sensor data, yes.
because
That
it's
might be also interesting.
In sports a lot now, they're using a lot of sensors, and this is a hot topic for sports, is what to do with all of this data and how to learn from it as well too. And I
Okay.
like kind of the aspect of IoT as well, getting data from there.
Okay. Yeah, image data and all those.
What is
What
network?
exactly is in the sports analytics section?
Yeah, yeah, yeah. So
Like anything
this
related?
one's easy. This one I'll be done quickly. I finished this class
Okay.
already. Then it's just
Okay.
because this one is more domain knowledge, Sujay, right? It's more about
Correct.
like knowing the
Correct.
sport,
That
knowing
particular sports, what kind of data is available, how they
what
relate,
models.
what
Yeah,
kind
what
of
models
analysis is
are
easier.
exactly.
Yes. Like
Exactly.
soccer and baseball, I imagine will like happen quite differently.
It's more
Soccer is
about,
like
yeah,
continuous,
super easy.
baseball is like pitch by pitch,
You got it.
like cricket. Yes, I
Got it.
can imagine that. Yes, makes sense.
This one's super doable. I'll be in these two classes for sure. So maybe we can talk about some soccer and baseball also. So I'll have to
Yeah,
talk to you.
yes,
Um,
sounds good.
I think that'll be fun. The problem is that class is taught in R, so I have to go back and learn R a little bit more also. So uh,
Okay, no, that's not difficult. You have Gemini and other AIs and all. You
yeah,
can use the code part.
okay. So okay, so this is helpful. I'll take a look between this. I'm excited about the reinforcement stuff. That's exciting. So maybe between reinforcement, sensor data, any of the other ones I should look into?
You can look into the deep learning part. I don't know what depth they will cover. The statistical machine learning is probably more into those HTTP kind of thing. Can you just over
Yeah, this is
that one?
that's supposed to be the hardest class that's there in the program. So
Okay, so practical machine learning, generalization, robustness, and fundamental concept of probability and statistical theory, machine learning topics from the viewpoint of statistics. Okay, this is like the classical statistics thing.
yeah, yeah. Wow. This is under comp department, so yeah.
What's the distinction comp and the other things?
Comp, so the main difference today is that the comp classes are taught in Python and it's under the computer science department, so it's more computer science heavy. The ELEC classes are under electrical engineering, so they're taught by electrical engineering professors. They don't do as much coding, it's more like theoretical stuff. And then we have
Okay,
like the stat classes are all taught in R and it's taught by the
okay,
statistics professors.
okay, understood.
So okay, buddy, this is helpful. I'll think
Okay,
about it and let you know.
yeah, yes,
Overall, though, summer from today can be kind of the last class for a bit because I don't really need that
okay,
much. Maybe the summer I might ask for one class just to kind of review some things that I've been learning, or maybe I
yeah,
learned some of this stuff and you want to like, get ahead of the class too. So I'll let you.
okay.
Oh, I don't know why I stopped sharing. Okay, this is what I want to look at today, Sujay. Let me